Hi everyone and welcome to our next lesson on this topic. Today we are looking at NPK. This is a triple science only topic. Remember that it would be useful for all of our videos if you had a pen or a piece of paper so you could work along with us during the video. Our challenge today is to be able to describe the importance of NPK fertilisers. Our aspire is to be able to explain how salts for NPK fertilisers are made. So before we go into the topic of NPK, it's worth us thinking back to bioenergetics and thinking about photosynthesis and plants and their growth. What do plants need to grow? Now, hopefully you're thinking of the following: light, water and carbon dioxide for photosynthesis. But hopefully you're also thinking of the nutrients that the plant needs from the soil. Now, plants need carbon dioxide and water for photosynthesis, but they also need small amounts of mineral salts for healthy growth. Now, plants get that from the soil when those mineral salts are dissolved when they are soluble. There are three main elements that mineral salts are. There is nitrogen, which is needed for the healthy leaves, phosphorus, which is needed for healthy roots, and potassium, which is needed for healthy flowers and for fruit. I typically remember that one because bananas, a fruit, have a really high level of potassium in them. I'm going to insert a video here that talks about fertilisers in detail. If you want to watch the original video, the link is on the screen also.
Put simply, fertiliser is plant food. It can be natural or deliberately put into soil by people. Fertiliser contains different kinds of nutrients that are essential for plants to grow. Ever since people started farming plants for food, thousands of years ago, they've had to manage the quality of soil on the land. When soil contains lots of essential nutrients, crop plants can grow fast and produce large yields. But when we harvest crops and then take them away and eat them, we take the nutrients too. So after years of growing plants, the soil can't support crops very well, unless we replace the nutrients using fertiliser. Most fertilisers contain nitrogen and phosphorus, though some contain other useful elements like potassium. They can be organic or inorganic. Organic fertiliser contains carbon, and an example of an organic fertiliser is manure. Inorganic fertilisers can take many forms, such as ammonium sulfate, which can be in a crystal or a powdered form. Since we learned how to make fertilisers efficiently on a large scale, we've been able to grow many more crops, and therefore the human population has risen dramatically. There can be problems with putting too much fertiliser into a natural system, and some of the problems with fertilisers are explained in other videos. So, a fertiliser is a plant food that contains nutrients such as nitrogen and phosphorus, and we use it to grow our crops bigger and faster so they produce more food.
So now that we've watched that video, I'd like you to answer the questions on the screen. I'd like you to describe what fertiliser is, Name the elements found in fertiliser and explain why fertilisers need adding to land which is used frequently for farming. Okay, so fertiliser is a substance which is added to soil to aid plant growth. The elements found in it are nitrogen, phosphorus and potassium. That's what the N, P and K stand for in NPK fertilisers. When plants grow, they use the nutrients in the soil. This needs replacing, which can be done by adding natural or artificial fertilisers. So now we're going to have a little bit of a look back to neutralisation when we looked at this in an earlier chemistry topic. Most fertilisers are made by the reaction of an acid and an alkali. Now in the table you can see the fertiliser names, so we've got ammonium nitrate, ammonium phosphate, ammonium sulfate and potassium nitrate. What I'd like you to do is I'd like you to name the acid that was used to form each of those fertilisers. Okay, so to make ammonium nitrate you would use nitric acid. For ammonium phosphate you would use phosphoric acid. For ammonium sulfate you'd use sulfuric acid. And again, for potassium nitrate, you would use nitric acid. Fab. So what we're going to do now is we're going to look at some of the sources of each of those minerals in fertilisers. So sources of nitrogen first of all. Now you may remember from the Haber process that ammonia is used to manufacture fertilisers. Now ammonia, NH3, is actually an alkali, and when it's involved in neutralisation reactions it produces the ammonium ion, which is present in a lot of fertilisers as it's a source of the nitrogen. However, it can also be oxidised to make nitric acid, which is the source of the nitrate ion. Ammonia can be neutralised by nitric acid to make the salt ammonium nitrate. So that actually is a source of 2 atoms of nitrogen. And that can be represented by the following equation. So that's ammonia plus nitric acid makes ammonium nitrate. Sources of potassium. Minerals are extracted from the crust, which can be used as fertilisers or as raw materials from which to make fertilisers. Potassium chloride and potassium sulfate can be used as fertilisers because they contain potassium ions. For sources of phosphate, phosphate rock unfortunately cannot be used as a fertiliser because it's insoluble. So instead we would use it to make fertilisers. Phosphate rock contains phosphorus compounds, and when it reacts with acids, useful soluble compounds are made. So, phosphate rock will react with nitric acid, and the compounds that are produced are calcium nitrate and phosphoric acid, which can be neutralised with ammonia to make ammonium phosphate. Phosphate rock reacts with sulfuric acid, and that produces single superphosphate, which is a mixture of calcium sulfate and calcium phosphate. And it also reacts with phosphoric acid, which produces triple superphosphate, which is also known as just calcium phosphate. Now, think about everything we've done so far. What makes a good fertiliser? And I want you to explain why certain elements are needed in fertiliser. Okay, so a good fertiliser contains soluble salts of nitrogen, phosphorus and potassium. Remember, they have to be soluble or they can't be absorbed by the plant. Nitrogen for healthy leaves, phosphorus for healthy roots, and potassium for healthy flowers and fruits. Now, ammonium sulfate can be made in different ways. Ammonium sulfate is a salt used as a fertiliser. It can be manufactured by reacting ammonia solution with sulfuric acid. In the reaction, ammonia plus sulfuric acid forms ammonium sulfate. Now remember, that is a neutralisation reaction. There are two different methods in which we can produce ammonium sulfate. There is a lab-based method, which is very similar to a titration, and there is an industrial method, which works from raw materials. I'm going to ask you to compare these two methods. Now on the next slide, there is a table of information about them all. What I'd like you to do is when I show that, if you could pause the video and then start to write your comparison. Remember, if you are comparing, you need to give similarities and differences. So remember to pause when the table comes up. Okay, so industrial methods produce large quantities of ammonium sulfate quicker than lab-based methods. The equipment is more expensive and higher temperatures are used, which will increase your energy costs. However, the equipment in use reduces labour costs compared to lab methods. Industrial methods work from raw materials, whereas lab methods depend on chemicals that have been purchased from suppliers. So you may have noticed in the industrial method we are working with materials that come from the earth, whereas in the lab method you are purchasing the acid and the ammonia ready-made from industry. Both of those methods actually overall use the same chemical reaction. So they are both reacting ammonia with sulfuric acid to form that ammonium sulfate. Now I've summarised these in a Venn diagram here. So industrial, we're looking at large quantities produced quicker, a much higher temperature used and very expensive equipment but low labour cost. And you are using raw materials, which technically can be cheaper. Both of these processes use the same reaction overall. The lab produces small quantities, slow if you wanted large quantities. So if you wanted a large amount of ammonium sulfate, you would have to keep repeating that method until you obtained it. They are cheaper in terms of the equipment and the energy that is being used, and they are using reactants that are purchased from a supplier. So it's time for us to look at some exam questions. You'll probably notice that some of these actually link into what we learned last lesson on the Haber process, and that's because the ammonia from that process is used to make a lot of these fertilisers. So the first question, the Haber process is used to produce ammonia from nitrogen and hydrogen. The equation for the reaction is nitrogen plus hydrogen makes ammonia. An ammonia molecule has the formula NH3. How many atoms are in one molecule of ammonia? What does the symbol mean on the screen? And then they'd like you to match each gas to a source of that gas. Remember, if you need more time, feel free to pause the video. Next question. The diagram shows the Haber process. A mixture of ammonia, hydrogen and nitrogen gases leave the reactor. Table 1 shows the boiling points of the gases. The mixture is cooled to a temperature at which only the ammonia condenses to a liquid. Which temperature could be used? So the next question, what happens to unreacted nitrogen? Then ammonia from the Haber process can be used to produce fertilisers. Table 2 gives information about 2 compounds used in fertilisers. So we've got compound A, which is potassium chloride, and compound B, which is diammonium phosphate, and their cost in pounds per kilogram. What type of bonding is present in potassium chloride? So table 2 is in use again here, so I've put it back at the top of this slide for you. Question G, diammonium phosphate has the chemical formula NH4 bracket 2 HPO4. Which 2 elements in that formula improve agricultural productivity? A farmer uses fertilisers A and B on a field with an area of 0.05 kilometres squared. 50 kilograms of fertiliser A will cover an area of 0.01 kilometres squared. Calculate the cost of fertilising a field with an area of 0.05 kilometres squared with fertiliser A. Use table 2. Then fertiliser B is more expensive than fertiliser A. Suggest why the farmer uses both fertilisers. Now the last few questions, question 2a, ammonium nitrate is another salt. Ammonium nitrate is made when an ammonia solution is neutralised with an acid. Name the acid to complete the word equation. Okay, so for the next one I need you to read the information on the screen. So you may need to pause the video to give yourself a little bit more time. The question to answer at the end of that information is, why do some farmers put ammonium nitrate on their farmland? Okay, which one of the questions in the table cannot be answered by science alone? They want you to choose one and then give 2 reasons why that question cannot be answered by science alone. So let's go through the mark scheme. 1A was for. The symbol was that it's a reversible reaction. Hydrogen comes from natural gas or from methane from natural gas, and nitrogen, the source, is the air. You'd have to cool it to -40 for the ammonia to liquefy, and the unreacted nitrogen and hydrogen are recycled into the reactor. Now, a little bit of paper 1 revision. It is, of course, an ionic bond between those 2 elements, as you have a metal and a non-metal. And the 2 elements that improve agricultural productivity in that formula were nitrogen and phosphorus. The cost of fertilising that field was £60. And the reason that the farmer used both fertilisers is he needed to use nitrogen, phosphorus and potassium. You could have said that he needed all of the nutrients, and neither of those fertilisers did have nitrogen, phosphorus and potassium in them. For 2A, the acid would be nitric acid. B, because it is a fertiliser and it will help plants grow. And the question that could not be answered by science was, should farmers stop using ammonium nitrate on their land? And the 2 reasons why is it can't be answered by an experiment, and it's based on opinion. You could also say that it's an ethical or economic issue. Okay, so that's everything for this lesson, and I will see you soon. Bye!